Right, Mr. Claxton's Algebra 1 students, the goal right now, what we are trying to accomplish, is to add and subtract expressions and combine like terms. Now that's what we were doing in 2.6, and we're still doing it in 2.7, but we are just adding an element to it. We are multiplying expressions that contain variables, and then dividing expressions that contain variables. And this section is it's vast in the knowledge that you need to complete some of these skills. We did discuss these examples in class. If you need to, pause, look over the example, try it again. Pause, look over the example, and try it if you think that you're going to be confused. You did need to complete these 5. For work, classwork. And then moving on to tonight's homework. In tonight's homework, 17 to 45 all, you had division, you had multiplication, and then you had multiplication through the distributive property. The blue examples right here all involve the distributive property to some degree, so watch out. When you get to those, you got to watch out. Now, we've been learning about the distributive property long enough to where I think you're going to do well on those. The red ones are division problems, so I just want to make sure that you know how to handle division problems. The first thing that you do is write the division problem out. We have negative 66x divided by 2. In high school, we write these as vertical fractions, and the reason why is because we start thinking about this as a rational expression and not as a fraction. I know you might be thinking fraction, but hey, we call them rational expressions. We're above that now. Another reason why I like you to think about it as a vertical fraction is because we can break this negative 66 up into factors of negative 66. So negative 33 times 2 divided by 2. And I know negative 33 times 2 is still negative 66. What this allows me to do is say, oh, I see a 2 over 2 there. I am allowed to cancel common factors. I cannot cancel parts of sums or differences. Again, you cannot cancel parts of sums or differences. You can only cancel common factors. So I cancel out the 2's. That's one group of 2 and one group of 2. 2 over 2 is the same as 1 over 1. Negative 33 times 1 times x is negative 33x. And then we have a 1 in the denominator. When we divide that by 1, we get the same value. So my answer is negative 33x. Circle your answer, move on to the next problem. In the next problem, it was a traditional multiplication problem, here in black. Negative 1 2/10 times 3x. Now I know today we rewrote, so I'll rewrite this one, negative 1 2/10. Get that decimal down there. Always make sure your decimal sitting down low. Negative 1 2/10. I'm going to put that in parentheses, just so there's no confusion, times 3. Now, I want to focus on that first. I asked myself there, in order to do this mentally, I asked myself, what's 12 times 3? Well, or negative 12 times 3, rather, would be negative 36. So if negative 12 times 3 is negative 36, I know all I have to do is move the decimal point back 1, because this is 1 2/10. So move the decimal place back 1 means we move it from here back 1. If you remember at the beginning of the year, we talked about that. So we get negative 3 6/10. Negative 3 6/10 x. Use a little mental math there. In 25, whoa, watch out. Watch out, we got the distributive property coming at you here. We have 7x squared minus the quantity 3 minus x squared. In order to complete this problem, I have to distribute that negative through, and that's something that we're struggling with right now. A lot of teachers draw arrows, which have no mathematical meaning, but they can help you to remember. So how we are going to think of this is 7x squared minus 3. And I'm going to go ahead and change my color. I'm going to change it up there because I had to think about that. I had to say, oh, that's minus 3. And then here we go again. Oh, minus a negative, or what's a negative times a negative? Oh, I know what a negative times a negative, Mr. Claxton. Anytime you multiply two negatives, you're going to get a positive. So that's going to create plus x squared. Now that we've distributed, and done it well, by the way, with color, hopefully you can see right there, we distributed that negative through, and really that's like saying plus negative 1, and that's why we're allowed to do that, but that's for a different discussion. Now I need to combine like terms. So the like terms in this particular expression, we've got, find brown here, we've got 7x squared, and then we've got plus x squared. So 7x squared and x squared, that's 1x squared, are going to give you 8x squared. And then all we have left is minus 3. You need to make sure that you are not trying to combine the 8 minus the 3, because they're not what do we call that? Like terms. They are not like terms. They do not have the exact same variables. We have another distributive property problem in 27. In 27 here, we actually have a number with it. So we start with x squared, and we have that pesky negative again. Pesky negative. And remember, we're basically multiplying everything inside the parentheses, everything inside these parentheses here, times negative 2. And how are we allowed to do that? We're allowed to do that by that keep, change rule I taught you. I could call this plus negative 2 if I wanted to. And that helps some people to take that plus negative 2, because then they say, oh, Mr. Claxton, you're multiplying then negative 2 times 3. And then you're multiplying, we'll go ahead and go with a really light green here, the negative 2 times the x squared, or negative 2 times negative x squared is what I would call that. So remember, that can be helpful. I'm going to go ahead and take it back to what it was, just because most students will look at that and see, oh, I'm multiplying negative 2 times 3. I know a negative times a positive is a negative, so that's going to be minus 2 times 3. And then I have a negative 2 times a negative x squared. So anytime we get that negative 2 times the negative x squared, I know a negative times a negative will yield a positive, and that's why I'm going to put a plus there. Now understand, that is a minus, and that is a minus. Okay, a minus and a negative, aren't exactly the same, but we could make that a negative. All right, so plus x squared. And now I combine like terms. I see the x squareds in there, and you should too. And that's 1x squared plus 1x squared. Oh, Mr. Claxton made a mistake. Oh, look at that. I'm going back and checking my work right now, and you should have been screaming, Mr. Claxton, stop. No, don't do it. Okay, instead of restarting this video, I'm going to go back here. Oh, look at what I forgot to do. I was focusing so much on the signs that I forgot about that 2 right there. That 2 has got to be there. That's positive 2x squared. Okay, a negative 2 times a negative 1. It's a positive 2x squared. There we go. Whew. Corrected that mistake. Acknowledged that mistake. Now let's move on. That gives me 3x squareds minus 6. Minus 6. And typically that minus sign is going to be longer than a negative as well. Now, could I call that 3x squared plus negative 6? Absolutely, but Mr. Claxton desires this form right here. So I hope that you've learned something, and this should definitely help you on your homework. Happy simplifying, everyone.